Hey Anna, so glad you're here. We're totally diving into the quantum computing company landscape today, right? Absolutely, Stella. I'm really excited. The thing is, this space is just exploding. It's not just the big names, like IBM and Google, but also tons of nimble startups are carving out their own niches. It's truly a global race, and it's fascinating. Yeah, it really is. It feels like every other day there's a new breakthrough. So, when we talk about the big players, who's really leading the charge right now in hardware and software development, and what's making them stand out? Oh, that's a great question. Well, obviously, IBM, right? They've been at it for forever with their superconducting qubits and that massive fleet of quantum systems. And then you've got Google. They totally rocked the world with their quantum supremacy claim back in 2019 with their Sycamore processor. That was huge. Wow, I remember that. It was a big deal. What about Microsoft and Amazon? Are they playing catch up or are they doing something different? No, not catch up at all. Microsoft, they're really pushing that topological qubit architecture with Azure Quantum, which is super ambitious. And Amazon with Bracket, they're focusing on giving everyone easy access to a whole bunch of different quantum hardware, which, is really democratizing the space. That's super interesting. So it's not just the established tech giants then. What about these nimble startups you mentioned? What kind of cool new stuff are they bringing to the table that maybe the bigger companies aren't focusing on as much? Totally. These startups are actually incredible. Take Alice and Bob, for instance. They're using these cat qubits that self-correct errors, which is a huge deal for fault tolerance. They've managed bit flip times of over 7 minutes on a single qubit. 7 minutes? That's wild. And what about different approaches to qubits? I hear about trapped ions, neutral atoms, all sorts of things. Is there one that's really showing more promise than others right now? Well, it really depends on what you're trying to do. IonQ, for example, is crushing it with trapped ions, even reaching 36 algorithmic qubits. And then you have atom computing. They're doing amazing things with neutral atoms, demonstrating a 1,225 site atomic array. That's one of the largest publicly disclosed systems. Wow, that's really, really big. So, scale is a huge factor, obviously. Are any of these companies making quantum computing more accessible, especially for, businesses that aren't necessarily quantum experts? Definitely. Companies like Classic are building these amazing software platforms that automate the creation of quantum circuits from high-level models. It's you don't need to be a quantum physicist to design complex algorithms, which is a massive step for broader adoption. And it's making it so much easier for enterprises to actually use this tech. That's fantastic. Making it more user-friendly, that's key. So, how are these companies actually translating all this incredible tech into real-world impact? What industries are seeing the biggest transformations or potential from quantum computing right now? Oh, loads. Finance is a big one for optimization and risk modeling. Healthcare and pharmaceuticals, they're using quantum for drug discovery and molecular simulations, which is huge. Boston QSci just simulated jet engine performance with only 30 logical qubits, which would have taken millions of classical cores. Whoa, that's a pretty mind-blowing difference. So it sounds like the applications are really starting to broaden beyond just, the theoretical. What about security? Is anyone tackling the post-quantum cryptography challenge? Absolutely. Companies like PQ Shield and Crypto Quantique are super focused on that. They're developing post-quantum cryptography and quantum random number generators to, future-proof our digital systems against quantum attacks. It's a critical area, really. That's good to hear, because that's a scary thought, right? So, looking ahead, what's next? What's the biggest hurdle or the most exciting development we should be keeping an eye on for, say, the next couple of years? I think error correction is still the biggest challenge, but also where we're seeing the most exciting progress. Companies like Riverlane are entirely focused on solving it. And then the move towards fault-tolerant systems and scaling up to millions of qubits, that's the holy grail, you know? It's all about making it practical and truly useful across every industry. It's a really exciting time to be in this space. It certainly sounds like it. Thanks so much for breaking all that down for us, Anna. It's been incredibly insightful. My pleasure, Stella. And that wraps up another episode of Impact Quantum. Make sure to like, share, and subscribe to stay on top of all the latest quantum news. And for even more in-depth insights, visit impactquantum.com. We'll catch you next time.